So yesterday we were speaking about VPN. Once again, this is part 2, where we'll be discussing more about how the VPN configuration will take place. So if you just try to warm up with yesterday's session, I explained you why we should go for VPN, what is the reason for VPN, and why we should prefer IPsec VPN. What are the two flavors of IPsec VPN? One is site-to-site VPN, and the another one is remote VPN. In remote also there are two flavors. One is AnyConnect and SSL VPN. So we were discussing about site-to-site VPN first, and while discussing, I told you IPsec is also having two modes. One is tunnel mode and transport mode. In the tunnel mode, all the data, IP header, everything gets encrypted. The default is tunnel mode. When it comes to transport mode, only the data is encrypted. Rest all is exposed. So I gave you the definition. In tunnel mode, the actual IP address and the original IP header along with all the data within the packet are protected. Okay. We were discussing about the 5 important steps that my IPsec is going to take in order to fulfill or in order to build a secure network or in order to make a secure communication between two peers, between two sites, or in order to make a tunnel between two peers or two sites. So IPsec operation is broken down into 5 primary steps. One is interesting traffic. So I told you interesting traffic is something like, I define with the help of ACL, access list. I specify the source, I specify the destination, I specify the networks which is going to go inside the tunnel. Because it is not necessary that all the traffic should go inside the tunnel. I want only a specific traffic should go inside the tunnel, which is interesting, which is important, which is to be protected. Or you can say, I will send only those traffic inside the tunnel which I want to be protected. That's all. All the other traffic should go outside the tunnel. This is the meaning of interesting traffic. Okay. Now, when we talk about second step, it is phase 1. Now, phase 1 is like, something where, there is some preparation is going on between two peers. Okay. What is the definition of phase 1? A basic set of security services are negotiated and agreed upon between peers. So suppose if you are forming a business in partnership or you are doing something, with some friend, you always have a discussion. You always discuss what will be the terms, what is the location, what is the product, like you're setting up a business. Discussion is going on. You're not just starting a business and investing, you just discuss. So phase 1 is where a basic set of security services are negotiated, decided, and agreed upon between peers. Because for making a VPN tunnel to work, you need to have a same set of security services running on both the ends. In fact, I told you in the first session, that first lecture of VPN, that both the devices are equally participating in VPN. They are both intelligent enough to participate in VPN. Earlier, we were not having that much good routers who used to support VPN. But later on, they made it like that, all ISR routers, ISR routers. Now you must be aware that what is the meaning of ISR, Integrated Services Router. Then ASR router, then CSR router, Cloud Service Routers, and ASR routers also. Now all this series can handle or can do VPN, or you can set up VPN on these routers. And I told you, VPN is not only supported on routers, it is supported on firewalls also. And not only on ASA, all the next generation firewalls like FTD also support VPN, site-to-site VPN. So routers support site-to-site VPN, ASA supports site-to-site VPN, FTD supports site-to-site VPN. So all of them support site-to-site VPN. So if two site or two location trying to do VPN, they will agree some security services. And these security services will protect all the subsequent communication between peers. So make it a point that until unless phase 1 is up, your phase 2 will never come up. So it is very important that your phase 1 should go successful. So in layman example, if I tell you that phase 1 is nothing but like, somebody told me that last month, in fact, I saw also that some prime minister, respected prime minister, so Modi is going to inaugurate some metro train. So it is the protocol or the security arrangement is like that you won't believe the whole area, almost say 2-kilometer radius of that area where he is going to visit for inauguration was secured. That means people who are continuously working 15 to 20, 1 month before, continuously working on the security of the area. And you won't believe they came to the building, they saw the terrace, they even found out who's working in these offices, which is nearby this railway station. Every possible, possible, whatever possibility these intelligence services were handling, they checked it. Even people who are coming to their offices were asked with their names, their identity, where they work, where they stay, what is the names, what is the post. Because you must have seen in movies and all they show, somebody is suddenly being working as a waiter, or somebody is working as a employee in some company, and then he do some kind of killing. Okay, he shot somebody. So actually speaking, they always verify the people who are working in the nearby offices because they don't want any threat from anyone. A routine check, a protocol. So phase 1 is nothing but you are setting up a security arrangement, or you are planning that, okay, on so and so day, Mr. X is going to visit this very important person. He is having a risk of his life. So what is the arrangement? So you won't believe the path is being set from where to where he is going to travel. How many cars will be there? What is the security arrangement? Where is going to
activate हो गया मुना ये क्या होगा प्लीज होगा
guys, mute yourself please. Adnan, Jahid, Nitin. Okay, so phase 1 is something which is very crucial, important. If your phase 1 is not up, your phase 2 will never come up, and your phase 2 never comes up, your data is not going to transfer. If your data is not going to transfer, and if your phase 1, phase 2 is not completed, then how are you going to break the tunnel? Or tunnel termination is not possible. So all the steps are dependent on phase 1. And phase 1 is the second step IPsec is doing. Like, you are telling me that I want to do, I told you I gave the contract of my house to someone. And the first day itself, he came and did the painting of the house. You imagine, can he do the painting of the house on the first day? Not possible. First, he's going to do some cement work, that is masonry works, tiling. Okay, then he will do some plumbing work. Then he will do some electrical work. So painting comes in the last, man. It is not the first day, suddenly he will paint. and then later on he will start working. So what will happen? The whole paint will go bad. So always remember there is a sequence. There is a procedure that VPN follows. That is IPsec VPN follows. So I'm asking IPsec VPN, how are you going to proceed with this? So he's telling me, boss, I'm going to follow 5 steps. The goal of IPsec is to protect the desired data and with the needed security services, and it is broken down into 5 steps. One is interesting traffic, second is IKE phase 1, third is I phase 2, where you see you're going to set the transform set, you're going to decide which algorithms you're going to use for encryption of data, integrity of the data, and definitely authentication. Everything will be decided there related to data. And then the data will come and get transferred from one end to another. I told you VPN is bidirectional. So your data can come from head office to branch office, or branch office to head office, or branch office to branch office also. Not a big deal. It's like, I told you last, site to site is also there. Hub to spoke is there. Spoke to spoke is there. Full mesh is there. Hub to spoke to hub, and hub spoke to spoke. Lot of topology you can do it. Okay. Now, when we talk about again phase 1, see, we are slowly moving from the definition to the procedure or the way IPsec is going to handle. And what is the sub protocols of IPsec? I told you, ISAC MP, the synonymous word is IKE version 1, IKE version 2, ESP and EH. IPsec is broken down into 5 steps. Interesting traffic, IKE phase 1, IKE phase 2, data transfer and tunnel termination. Don't keep the tunnel open. Like for example, you feel like sitting, on a chair, like, a very good chair in a garden. So you do one thing, you carry that chair in your car and just sit there in the garden with that chair. But after finishing, what you're going to do? If you leave the chair like that, what will happen? People will take away that chair, or people will sit on that chair. So what you should do? You fold the chair and take it home, no? Or you're keeping it there. No, I will be coming tomorrow. So when you come tomorrow, again you bring the chair. Because if you keep it open, what will happen? People will sit on that chair. People might misuse that chair. People might take away that chair. So why you are keeping that chair open? Why you are keeping your tunnel open when your job is done? So once your job is done, tunnel terminate. Like for example, you have logged in into a bank account. You see, earlier we used to keep it login only. Whole day you want to take out the money over or transfer money, no. So now what happened? The banking website, they have some automatic logout. So if they see inactivity for some time, they will immediately log you out of the banking website because it is dangerous. If you are keeping your bank website, online banking website open, logged in, anybody can misuse that. So what is the best practice? Once your job is done, see that you log out. So when you go to ATM and try to take out money, once you finish, you cancel. Take out your card and go home. Okay. So now in phase 1 also you have 2 modes. One is main mode and the second one is aggressive mode. Now when we talk about main mode, I'll show you. See here. This is the main mode between router A and router B taking place. So in the main mode, the first thing that happens is what? Negotiation of policy. Again, IKE phase 1 carries 2 modes, main mode and aggressive mode. In main mode, what happens? Negotiation takes place between the 2 devices, routers. What kind of negotiation? Regarding the policy. That is why the term is negotiate IKE policy. So you must be thinking, what is the policy? They are deciding haggle. Haggle means what? It is a short-term acronym for hashing, authentication, okay, group, lifetime, and encryption. Haggle means what? Hashing algorithm, authentication, group, lifetime, and encryption. So everything has to be decided. So let's say you have decided, or you have 2-3 policies with you, and the other guy is also having 2-3 policy with related to hashing, encryption, Diffie-Hellman, lifetime. Now you must be wondering, what is Diffie-Hellman? I'll tell you. Okay. So in this clip or in this image, you see policy 10. See, number is okay. You don't have to match the number. Policy 10, policy 20 on router A, policy 100 and policy 200 on router B. So number need not to be matched. So any number can be there, but sorry, encryption AES 256 is not matching with encryption 3 days on the other side. Authentication RSA is not matching with pre-shared key. Diffie-Hellman is not matching with. So now you must be thinking, what is encryption? You know, encryption algorithms are used to encrypt the content so that nobody reads the content, to maintain the confidentiality of the content. Okay. Now what about Diffie-Hellman? Diffie-Hellman were two professors who came out with symmetric keys and asymmetric keys. Now symmetric keys means what? So before going for Diffie-Hellman, I want to tell you that, you see, this is not matching. Why? Because you see, encryption is not matching. This can be anything, so no problem. But encryption algorithms is not matching. Authentication is not matching. Diffie-Hellman matching. Okay. Lifetime is matching, so it's okay. But remember, you don't need to match lifetime. You can keep anything here, you can keep anything there. Not a big deal. Default lifetime is 86,400 seconds. So anyhow, both of them started negotiating with the policy, and you won't believe, this is the policy get matched with this. And this is one who is not matching. So we'll consider this policy. On router A, we'll consider policy 10. On router B, we'll consider policy 200. Now what? We'll go and discuss what is the authentication method, pre-shared and RS. Now, if I talk about authentication, you know, what is the meaning of authentication? Who are you? I'm trying to find out, because they said, if you are, see, peer authentication, the third exchange. Second exchange is Diffie-Hellman. First exchange is about the policy. So second exchange we'll discuss first, that is Diffie-Hellman key. So Diffie-Hellman were two professors, they came out with symmetric keys in the beginning, which says Like for example, suppose I am going to my village out of town. I'm leaving my city and going out. So I would do what? I would just bring one suitcase or many suitcase, might be 2, 3 suitcase, where I'm going to pack my clothes and other important stuff that I need there in the town. So suppose I am having 2 to 3 suitcase that I want to carry for my native place for the vacation. Now, once I pack the things, what I do? What is the next? I lock it. But when I lock the bag, I also carry the key with me. Is it possible that you lock the bag and leave the key here only and then you leave? Many times happen by mistake or in a hurry, you forget the keys or you lose the key. Then you have to break. But here, in symmetric keys, they said once you do authentication, once you decide, you have to carry the key from one end to another. That is called symmetric key. So suppose you are carrying the bags, you should carry the key. Because once you reach there, you have to open the bags. But the problem is you might lose your key. Somebody might forcefully take away this key and open the bag. Somebody might rob your key. Find out your key. Why? Because the key is going from one end to another end over internet. So suppose you're sleeping in a train or in a bus going towards native. Somebody might take it from your pocket, open the bag and rob all things which you are carrying. So risk is there. Because you are carrying the lock, you are carrying the key also with you. And that is called symmetric keys. So later on they came with asymmetric. What is asymmetric key? I'm going to generate, that is router A is going to generate private key and public key. Okay. But they won't send and they will club this key, private and public key of B. And it's going to make one key called shared secret key. So what is shared secret key? Shared secret key is the combination of router A's private key and router B's public key. That is called shared secret key. So in order to lock your data, you need a key or you are making a key which is called shared secret key. In this shared secret key, what I'm doing? I am using a combination of private key and public key of another router or another peer. It's algorithm. Can you see it's some formula? Private and public. And you see the result is same. YA and YB, XA and XB. So what happens? Router A generates two keys. One is private key and one is public key, and he sends his public key to this guy. And then he generates, router B also generates two key and he sends his own public key to this guy. Okay. So what happens? You see, in worst case, suppose while sending the key from year to year and year to year, hacker might rob it. And when the hacker robs the key, what he is going to do? He is going to club it with, either he is going to make these two key work, but it will not work. Why? Because I am not sending my private key. I am hiding my private key here only. I am not taking it. I am not carrying my private key. So if I am not sending my private key, what will happen? Hacker is not able to judge or find out what is the private key I am generating. Okay. So it becomes like, more secure. Your symmetric key is less secure compared to a symmetric key. So in your second exchange, if you see second exchange, you have Diffie-Hellman exchange. What is the second exchange? Diffie-Hellman exchange. So what is getting exchanged in this Diffie-Hellman exchange? It is the public key being exchanged by both these peers. For what? To club it with private key on both the ends and make a shared secret key. So in case if a hacker robs this key, both the public key, he will not be able to generate a shared secret key, because your shared secret key is designed with the private key and the public key of router P. Same, vice versa. Public key of router A and private key of router B makes a shared secret. So initially what happened, your IP I phase 1 will have 3 exchange. One is negotiating IKE policy, second is Diffie-Hellman exchange, and the third is what? Peer authentication. So policy means they'll decide which encryption algorithm you're going to use. Okay, they will decide which encryption algorithm you're going to use. Which authentication method you're going to use. When you saw, when we were doing this designing of the policy, you saw there was a method called pre-shared, if you remember. Now you must be wondering what is pre-shared. So in the first exchange, the policy is getting exchanged and the authentication decided is pre-shared. Pre-share means we mutually agree on a particular password. Like for example, we decided there will be a password called Cisco. So we mutually decided that, and that is why it is called pre-shared. You must have seen movies where when they want to smuggle something or they want to exchange something. So the code language will be there. Or I've seen a lot of movies where they'll tear the dollar and they'll keep one piece with one boss will keep one piece, another boss will keep another piece, and the day when they exchange this whatever smuggle things, they'll always match with these two tone notes or tone dollars, so that they know that this man is coming from exactly the same boss, this man is also coming from exactly the partner boss, and there's no in between police is coming in. So pre-shared means I should know what is pre-decided. They might use some code also, which a third party won't know what is the code. and then only the data will get exchanged. So when it comes to authentication, we always go for pre-shared method. What is that pre-shared method? I am going to manually tell the key on R1 and on R2, and it will be always the same key I have to mention. Clear? So the first step is what? Design a policy. In the policy, I'm telling you which encryption algorithms I'm going to use, which authentication method I'm going to use, and it should be same at both the end. Except for lifetime, you have to use same at both the end. What is same? The encryption algorithms, the authentication method, the Diffie-Hellman group, the lifetime, the hash, everything has to be same. Except for lifetime, everything has to be same. Then only your phase one negotiation of policy will get completed. Second is Diffie-Hellman exchange. I told you what is Diffie-Hellman exchange. Both the routers, both the peers are exchanging keys, that is public keys, and then they are mixing it with private key and generating a shared secret key. All these things take place in Diffie-Hellman group or Diffie-Hellman. Last but not least, integration algorithms. MD5 is there, here it is SHA. But in the second policy, you see both are having the same SHA policy. Secure hash algorithm. Okay, so phase one, first part is what? Phase one is divided into two: main mode and aggressive mode. In main mode, there are 6 messages being exchanged. How many? 6. Or you can say 3 two-way exchange. First exchange is what? Negotiation of policy. Second, Diffie-Hellman exchange. Third is what? Peer's identity. What is peer identity, man? With the help of authentication method, I'm trying to find out if I'm doing the tunnel with the right person or not, right peer or not. So if R1 is doing tunnel with R2, I can't see the peer, no? It is between two countries, it is between two cities, two states, whatever. The distance is, I cannot see. When you enter ATM center, my bank can't see you that, okay, you are so and so person and you are the account holder. They always verify your PIN number. They always verify your card. They authenticate and verify you. They authenticate you basically. So peer identity is very important. If your peer identity is not there, then you will end up doing a tunnel with the wrong guy. Might be with hacker. So what is the use? If you're doing a safe tunnel or secure tunnel with the hacker, ultimately you lost your data. So what is the point? Here the point is you have to see that you are going to make tunnel with whom, whether you know that person, whether you know that peer. So there should be some method followed, and the first important and secure method that people always go for is RSA. RSA again is the name of three very, very intelligent person like Ravish, Shamir, Adleman. Ravish, Shamir and Adleman. They were the three intelligent guys. They came out with RSA keys, digital signatures, certificate authorities. Like suppose you want to prove that you are a graduate or you are carrying a degree in masters or you're carrying a CCIE number. So you have to prove it with some certificate, no? You always show them your certificates. When you get appointed in some company, you hand over your certificate. You show them your certificates. So when you show them your certificate, they always verified, okay, which year you did your engineering, which year, which university, whether they have a seal signed from some authority or not. If they feel, okay, this is the genuine certificate, this is the proper certificate that you're giving, then they will approve you. If you're giving you fake information, they won't approve you. They won't take it as a authentication. So definitely certificate authority method is more and more secure method rather than pre-shared key. Because in pre-shared key, what happens? You're deciding the key and it can be leaked out, no? When you say the key or when you confirm the key, it can be leaked out. You cannot carry a certificate. Anybody cannot carry that certificate and prove himself. No, I cannot carry my friend's certificate and say, this is me. No, my friend's certificate carries his name. Everything is his. I cannot carry that certificate and show it to some company and say, okay, I am so and so person. No. So in 6 messages that are being exchanged between R1 and R2, that is between two peers or between the two devices which are going to do VPN tunnel. The first one is negotiation of policy. The second one is Diffie-Hellman keys exchange. And the third one is what? Peer's identity. And peer's identity is very important. Until unless you do the authentication of your peer, it is useless to form a tunnel and send the data. Data is very important. So once your phase 1 is completed, please try to understand. Once your phase 1 is completed, now again you must be wondering what is there in aggressive mode. I'll tell you. Aggressive mode, what happens? The same thing is done in 2 exchange, or you can say 3 messages are exchanged. Out of 6, there are only 3 messages being exchanged, and the same thing happens in a quick format, a quick way. So it is up to you. You want to follow main mode or you want to follow aggressive mode. What is the advantage you're going to get in aggressive mode? Whatever things you're doing in main mode will be done. There it takes 6 messages exchange. Here it will be in 3 messages. That's all. This is the advantage you're going to get. Now comes phase 2. Okay. See? Peer authentication. Diffie-Hellman groups. Groups means what will be the algorithm to generate that keys? What will be the keys? As per group, it will be more and more tough keys that they are going to generate. Okay. So we'll see the commands and then we'll discuss with this also. So in phase 2, what happens? Phase 2 VPN. You define the transform set. Now you must be wondering what is transform set in phase 2. Because once your phase 1 is ready, phase 1 is ready means with the help of either main mode or aggressive mode, you have done your phase 1 ready. You have negotiated the policy between two peers. Still your data has not come up. You are just making an arrangement. I told you, if Prime Minister is coming and visiting this area, they have made arrangement 1 month before. They are continuously looking into all the factors to maintain the security and smooth going of this function. Because there will be 100 people there waiting for the, for doing some wrong things. So they don't want somebody should do any wrong to the important person here visiting here. So they will always take care of all these things. Security will be beefed up. In fact, offices were told to close down for some hours. Shops were closed. Traffic was controlled in this area. In fact, you never know, they might have taken into custody of antisocial elements also for a few days without any reasons. They'll put them behind the bars so that they don't go and do anything wrong to anyone. Possible. Their way of dealing things, security. If they see you, they might question you where you're going, why you're coming, who are you. Though you are not the wrong person or bad person, still it is their job. Okay. So when it comes to doing side-to-side VPN between two routers, it is very important that you understand the configuration, the requirement of both the peers. Okay. So now what is the command for side-to-side VPN between two ASs? So first we'll see between two routers. Okay, I must have written here somewhere. One minute. I'll just check where I. So that I show you. It's simple basically. When I do the practical also, I will show you. That's not a big deal. But I made a, okay, see. So in this, first I enable ISAC MP. But now what happened? Now they changed this. They said, no, you cannot enable ISAC MP policy because now ISAC MP is again version 1 and version 2. So you say either you are going to do version 1 or you're going to do version 2. If you are going to do a version 1, then the command is crypto IC v1 policy and some number. So I told you, you have to do Haggle. What is Haggle? Hash encryption authentication group lifetime. This is phase 1. Phase 1 is up to here. I told you, you are selecting pre-shared key. If you are doing pre-shared key, you have to specify what will be the pre-shared key and who is your peer and where you have to send this key. So I'm sending this key to 12112. Who is 12112? My router. Because my setup is like that. Huh? Wait, I'll show you. This is R1 in between internet and R2. So this is 12.1.1.1 and this is .2. So I'm going to send this preset key Cisco to R2. Clear? Next is I'm going to specify the transform set. What is transform set? Transform set is nothing but a set where I decide or where I include the algorithms which will be needed for maintaining the confidentiality of data and integrity of the data. So I create some transform set. Transform set is like a container which carries the algorithms used for maintaining the confidentiality of the data and integrity of the data. And you know the sub protocol ESP is going to do that with the help of encryption algorithm AES. So there are many algorithms who are doing encryption. Like I said earlier, we used to have DES, data encryption standard. Then later on, we used to have triple DES. And then we used to have advanced encryption standard. So advanced encryption standard is more powerful than 3 DES and DES. DES is outdated because it was cracked. Getting it? Some of the algorithms are outdated. They are not needed. They are outdated because they were cracked. So we cannot use the algorithms which were cracked. For some reason, they were exposed. So, okay, transform set with the name T set, any name, carries the algorithms which are used for maintaining the encryption of the data and hashing. So, for integrity, sorry. So, for encryption, AES, for hash, SHA-HMAC, best algorithms. You have a choice. It is not necessary that you should always mention this. I was telling you about the interesting traffic. So what will be the interesting traffic? The LAN of R1 visiting the LAN of R2. And definitely on R2, you see the LAN of R2 visiting the LAN of R1, vice versa. This is nothing but interesting traffic. The traffic which is going to trigger VPN. Because see, I said if I'm buying a car, whenever I come near the car, my driver open the door, make me sit inside the car, and then he start the car and take me to office. Because I am interesting traffic for him. Whenever my other family member come near the car, he will take them to their destination. Because they are all considered as interesting traffic. So whenever I specify interesting traffic and the packet comes from this particular source and this particular destination, any packet, because you see I have mentioned any IP. IP means any packet. It can be ICMP, it can be TCP, it can be UDP, it can be any protocol and any service. I have not specified the protocol in service. I specified IP. IP means everything comes under IP only. So what will happen? Simple. It is going to trigger VPN tunnel because I told you don't keep the VPN tunnel on. Don't keep it on. If it is idle, let this tunnel get terminated because we don't want hackers to study this tunnel. We don't want hackers to learn this tunnel, to understand this tunnel. So we have to break the tunnel. If you keep your laptop open and then somebody comes and sit on your laptop, he might try to scan it. Scan means he will go and open some important files which you don't want anyone because this is your personal laptop. So if you're having a personal laptop, what you do? Safeguard it. Na? Like you give passwords to your mobile phone because if you leave your phones on table, somebody might access it. Somebody might take it, somebody might find out the context, somebody might read your messages. So what is your privacy is gone? You're chatting with someone and he might read those messages. You have received some mails, he might see those mails. You don't want all of them should see those messages and those mails. So you are going to safeguard it. So when you consider interesting traffic, it is just to trigger the VPN tunnel. Clear, guys? So today we'll stop here only. And again, we'll continue for VPN on Monday now. Because Friday, Saturday, Sunday, we won't have session. We'll continue on Monday. Okay? I hope you understood. Thank you very much. Take care. Have a nice weekend.